What if I told you a single graph could tell the entire story of a race car, a falling apple, or even a space rocket? Let's break down the speed time graph. Graphs are useful as they help us understand the data and the relationship between quantities. There are two types of motion graphs: distance or displacement time graph and speed or velocity time graph. This video covers the speed time graphs. A speed time graph describes the speed of an object per unit taken. A speed time graph has two axes, a vertical and a horizontal axis. A vertical axis represents the speed covered by the object. A horizontal axis represents the time taken by an object. The speed can be in meters per second or kilometers per hour. Time can be in seconds, minutes, or hours. The units to be used are based on the data given. The following are features on the speed time graph. A gradient or slope line represents constant acceleration. An upward slant represents acceleration. A downward slant represents deceleration. A horizontal or flat line represents constant speed or zero acceleration. The area of the graph represents distance covered. The area of the graph is calculated using mathematical methods. For instance, the shaded area of this graph can be found by dividing it into sections. Area A is a triangle, Area B is a rectangle, Area C is a trapezium, Area D is a rectangle, and Area E is a triangle. By finding the total area of these individual sections, we can determine the area of the shaded graph, and that represents the distance covered. The formula for calculating the area of a triangle is half times b times h. The formula for calculating the area of a rectangle is b times h. The formula for calculating the area of a trapezium is half times a b times h. A quick challenge. If a car moves at a constant speed for 12 seconds, what shape will represent its motion on a speed time graph? Drop your answer in the comments. Let's consider an example. A motorcyclist accelerates from rest to 5 meters per second squared for 8 seconds, then travels at a constant speed for 10 seconds. He then decelerates at 2 meters per second squared for 5 seconds and continues at a constant speed for 5 seconds. A. Draw a speed time graph. The first statement says that a motorcyclist accelerates from rest to 5 meters per second squared for 8 seconds. We can find the velocity from this data. Final velocity is equal to initial velocity times acceleration times time. Initial velocity is 0 as the motorist is from rest, acceleration is 5, and time is 8. This gives 40 meters per second. The first statement can now be plotted on the graph. Velocity is 40 and time is 8. The second statement says that he then travels at a constant speed for 10 seconds. Constant speed has a horizontal line on the speed time graph. Adding 10 seconds to 8 seconds gives 18 seconds, so the flat line goes up to 18. The third statement says he then decelerates at 2 meters per second squared for 5 seconds. We need to find the final velocity for this 5 seconds. Final velocity is equal to initial velocity acceleration times time. Initial velocity is 40. The acceleration is 2, but as the motorist was decelerating, then it's -2. And time is 5. This gives 40 minus 10, and finally 30 meters per second as the final velocity. The statement can now be plotted. Time is 18 plus 5, which goes to 23, and velocity is 30. The final statement says he continues at a constant for 5 seconds. This is represented by a flat line from 23 to 28. This is a complete speed time graph for the question given. B. Find the total distance covered by the motorcyclist. The distance covered is equal to the area of the graph. We can find the total area of the graph by dividing the area into small sections. Total distance is equal to total area, which is equal to area A, area B, area C, area D. Area A covers the first 8 seconds and it's a triangle. It's half times 8 times 40. This gives 160 meters. Area B covers from 8 seconds to 18 seconds and it's a rectangle. Then it's 10 times 40, which gives 400 meters. Area C covers from 18 seconds to 23 seconds and it's a trapezium. Then it's half brace 40 plus 30 times 5, which gives 175 meters. Area D covers from 23 seconds to 28 seconds, and it's a rectangle. Then it's 5 times 30, which gives 150 meters. The total distance is equal to 160 plus 400 plus 175 plus 150. This gives 885 meters as the total distance traveled by the motorist. To recap, a speed time graph describes the speed of an object per unit taken. On the speed time graph, a slope line represents constant acceleration. An upward slant represents acceleration. A downward slant represents deceleration. A horizontal or flat line represents constant speed or zero acceleration. The area of the graph represents distance covered. Speed time graphs don't just explain motion, they reveal the hidden patterns behind every acceleration and stop. Now that you've mastered this, in the next video, we'll explore distance time graphs and uncover even more motion secrets. Stay tuned, stay curious.